Hi, everyone. Welcome back. We are now attending the connected data frame of stage two, which is a technical stage. I hope you all had a really nice break and ready to get back into it. So, kicking us off first is Suraj Pillai. Suraj is going to be talking to us about data streaming and data mesh. How can you unlock your data in real time? Suraj comes to us from Confluent, where he's a senior solutions engineer. So, Suraj, over to you, mate.
Yeah,
I'll just stick around to make sure everything comes up. And
sure,
fabulous.
sure.
Good to go.
Okay, thanks, Akhil. Thank you guys for joining this talk. So I am Suraj, and I'm a solutions engineer with Confluent. The topic of today's talk is around data streaming and data mesh. So I hope to complete everything in the first 20 minutes, and then last couple of minutes we'll take your questions. Right. So let's get started on this. So let's understand before we dive into data mesh, right, what exactly is data streaming, right? And why do we need data streaming? So to understand that, we need to understand how traditional architectures work and what especially do we mean by data at rest. Now, this is typically symbolized by something like as a database, and you can run two kinds of jobs against this database. So you could have simple static real-time queries, which will give you the result at time t1. Or if you want a result at time t2, you would have to again run that query at that time to get that updated result. But every time you want some update, you need to run that query. So that's number one. The other kind of job which you can run are the batch jobs, which you would run at every X interval of time. You extract the data, transform it, and load it into some other system. But if you look at it, the database in all this is at the heart of the architecture. And not I'm just talking about databases here. It could just be any other monolith system, right, or any other kind of system. But what it essentially leads to is kind of a spaghetti architecture where you have a lot of point-to-point connections. Now, there have been ways and the architectures which have been devised to kind of work around it. For example, you could have an ESP layer, but there are some problems even there. So number one is the scalability, and number two is the middleware layer itself can kind of become the bottleneck, wherein multiple teams are asking them to change uh, some stuff at their end, but then they may not have the bandwidth to kind of do that. So that is a limitation there. So what we want to do is we want to make this data available, but there should be no bottleneck. And also the second most important requirement is the data should not be at rest. If you look at the architectures today or the kind of events which come in, we have events which come in from point of sale terminals. We have events which come in from, let's say, orders from an e-commerce website. So everything in today's world is an event. And we want to make sure that we process these events in real time. And this is where the data in motion or event streams come into picture. And this is where Confluent can help you. So if you look at it, I have all these events coming in from all these different places, a sale event or a trade event, so on. What I want to do is I want to capture these events, and just capturing these events is not enough. What's more important is what do I do with these events? I want to transform these events. I want to create value out of these events so that I can provide some rich customer experiences. And that is where the whole value lies of this entire platform. So if I were to talk about an event streaming platform, it should have four requirements. There are four properties which it should satisfy. The first one is it should be real time. The second one is it should be scalable. The third one is it should be persistent and durable. So that messages once consumed, it should not just disappear. It should still be there so that some other application can come in and consume that message again at some other point in time. That platform should be capable of enriching those messages. Now, if you look at all the other systems, for example, databases, messaging, so on, they satisfy some of these criteria, but not all. For example, if I take messaging, it is definitely low latency, and we'll come to that, right? So it's definitely low latency, but it doesn't support persistence and durability. of messages. And if you go to an ETL kind of platform, it's good for batch data integration. So the throughput is very good, but the latency is very high. And by what I mean is because the batch jobs, well, by its very definition, runs at fixed intervals of time, you are not getting real-time data. So if I want to have one platform or one kind of architecture which satisfies all these requirements, this is going to be an event streaming platform, which is scalable, it's real time, and you can have stream processing on top of that, so that you can have something meaningful data on top of that. So this is where Confluent comes in. So what we suggest is Kafka in this particular case, it becomes the central nervous system wherein all the data in your enterprise flows in and out of that particular system. So all these applications can connect into and tap into these events which are flowing. Now, when I talk about Kafka, it's not just a PubSub mechanism here, which I'm talking about. I'm also talking about the fact that there's a whole ecosystem around it. The number one is there are connectors which can connect to all these different systems and bring data into Kafka. And then you have a stream processing layer vis-a-vis KSQL DB, which you can think of it as SQL over Kafka. And then K streams, right? If you want to write more advanced Java code, you can have an opinionated library called K streams, which you can do stream processing. So it's this entire thing, which this ecosystem, which you can transform into a central nervous system for your enterprise, right? And it's not just a single Kafka cluster which you're talking about. It's not a physical Kafka cluster. It could be multiple such clusters which are talking to each other at any given point in time. So consider this scenario. We have all these devices which are running on the left hand side, and I have a connector which is running, or multiple connectors which are running, which are getting events from all these different sources and applications into Confluent. And I have a KSQL DB layer which is going to run on top of that, so that whatever events come in, I'm able to get some rich contextual information out of that. So you may then ask me the question, what is this KSQL DB layer doing, right? What exactly is it doing? How can it make sense of these events? So let me give you an example. So this is a typical KSQL DB statement. And if you look at it, it's a simple select statement, very similar to what you would write in your typical RDBMS. The only difference here is you would have something like an emit change, and also you have a window syntax here. Essentially, you can think of KSQL DB as being SQL over Kafka. The only difference here is instead of writing SQL statements against static data, which is what you would do with your normal RDBMS or any other kind of database, here you're writing that SQL statement and executing that SQL statement against data which is constantly in motion. So you could have orders data which is coming in from multiple places. You could have login details which are coming in. You could have log details which are coming in. And you want to aggregate all that information, maybe join that all those information to give you one consolidated view of what is happening in your system. So you could do that with KSQL DB. Now, what this statement actually does is this. So it's a possible fraud anomaly scenario wherein I'm checking if a card number has had more than 3 transactions in a window of 30 seconds. And if that is the case, then it's a case of possible fraud. Now, of course, the business rules may differ. But as you can see, this is happening in real time. We don't want a fraud detection to happen post facto, or once it's there in some database and then you wait for some bad job to run and then detect, okay, a fraud has happened at some point in the past. This is constantly being run on data which is flowing and hence real time. So that was about data streaming. And the I just kind of glanced through all the why do we need data streaming for, right? But then how does it relate to data mesh? And before we even go to data mesh, why do we even need a data mesh? What is a data mesh? So let me start by giving you an example. Consider a typical enterprise The way we would go about things is we would have all these domains. So let's say there's an orders domain, there's an inventory domain, so on. In case you're talking about a microservices based architecture, or even otherwise, even if it's a monolith, what would happen is all these domains would be sending data to some place, which is usually a data lake. So perhaps you would be sending data into Kafka, from there offloading that data into a data lake. And typically, post that information is in the data lake, there would be another team which takes up that data, kind of transforms it, cleans that data, and brings it into a format which is consumable by other applications. So once they do that, this data is then consumable by other applications. You could put it in a data warehouse on or some other OLAP system, such as maybe you could put it in in Apache Pinot or ClickHouse or something else. Now, once that is done, if you look at the overall architecture, right, the people in the middle who are actually extracting the data from the data lake and transforming and cleansing that data, they are not the owners of that data. They don't understand that data as well as the domains who have actually produced that data. So they may do things with the data which are not intended. So the first consequence of that is the data quality may suffer, right? The second point is, because you are now relying on a centralized team to make all these changes on your behalf, what is happening is the centralized team itself may become the bottleneck. And what I mean by that is, when you have multiple teams or domains who are sending requests saying that, hey, listen, I'm sending you a new kind of data. Now make use of it. And then there's another team who's doing the same thing. Now all these requests are in a backlog for this particular middle team. And what they have to do is they have to prioritize and take requests one at a time and make sure that they work on that request. But what ultimately suffers here is the agility, right? And the speed to market, right? How fast can I use this data so that I can provide some rich experience for my customers? Because that's the ultimate aim. So at a very high level, that's kind of the pain point we are trying to address here, and that is why have bought in or we have bought in a concept called the data mesh. And it's not a concept which is coined by us as such. It's a concept which has been brought up by Zamak from ThoughtWorks. So it's there. There are a lot of videos you can find around this, and there are a lot of white papers also. So what does data mesh intend to do, right? And to better understand data mesh, it's worthwhile to go into the four properties or the four principles of a data mesh, which will help us understand what it is. So the principles of a data mesh are these. The first one is domain-driven decentralization. The second one is data as a first-class product. Third one is it should be self-serviceable. And fourth one is federated governance. Next, what we are going to do is we'll dive into each one of these in detail or in some detail, and then we'll see how it affects how Confluent can help them. So the first one is domain-driven centralization. And what do we mean by that? So the first case, which is the anti-pattern, which is represented here, I have some applications which are sending data, and all of them are going into some data warehouse team, and the responsibility of that domain data is with the data warehouse team, which as I mentioned earlier, they may not totally understand what's going on with that data, right? Which is a problem, because you need someone who understands that data and what that data truly denotes. So for example, if there is a customer ID attribute in your schema, everybody should have some understanding of about what that customer ID is. I'm just giving you a very trivial example, but you understand what that problem is. So what we want to evolve this into is a pattern wherein the ownership of that data is with the domain itself. So what it essentially means is this. Let's assume that we have this data mesh. We have all these different domains, which are inventory, shipment, orders, and we have teams working on these domains. All these nodes which you see are essentially the data products which are published by this domain or exposed by this domain so that the other domains can consume from it. And the owners of this data are this domain. So that is where we want to get to. Now, if I were to give you an example here, let's assume we have order data and an order domain, an inventory domain, and a billing domain. Now, this order data has produced some data into, let's say, Kafka. And from there, Kafka is the inventory domain is subscribing to those messages. And when it's subscribing to that order data, what it finds is there's a problem with maybe some of the fields there. So there are two approaches which Joe from the inventory team can go about this. So he can either correct the data himself in his particular domain, or what he can do is he can contact Alice from the domain orders and tell her that, okay, listen, there is a problem with this attribute, you need to correct it. And the second approach is the valid approach if you look at it, because the order data is something which is consumed by multiple different domains. And the same correction may be required even maybe for the billing domain or even for the recommendations domain. So it makes even more sense that the data is corrected at the source where the ownership lies. So you are fixing owners for your data there. The second principle is data as a first class product. So what do we mean by that? So it's just not enough that you produce data. You need to make that data discoverable. It should be addressable. It should be trustworthy, and it should be secure, right? And it should be shareable with other teams. Because what good is data if you cannot share it with anybody else? The ultimate goal of having this entire approach is for each of these domains to expose the data which they are the owners of, and for the others to be able to consume it. Now, again, we'll go by the previous example wherein we have the data mesh, the same, we have the different domains and the data products they are which they are exposing to different domains. Now, how does one expose this data product to other domains? And the thing we have to note here is, especially in our current scenario, when you have all these different events which are flowing in, right? For example, the e-commerce website where you have orders which are continuously coming in. You have to make sure that these orders, for example, if I have some order product coming in the inventory domain, I want to make sure that the order information is available in real time to the other domains as well. So how can I do that? So one of the natural fitments to this particular scenario is Confluent and Kafka. So wherein you have all these data products which are there, and the way you would share all these data products is possibly via Kafka. Now, the way you would share data between Kafka, Confluent provides a very unique solution which is called cluster linking, wherein you just run a command, and what it will do is it will securely transfer data from one topic, from maybe the orders topic in a Kafka cluster, into another topic into a destination cluster. And from the destination cluster, multiple such teams can subscribe to that data and make use of that data. So this is one way you could do it. The other point where Kafka becomes really important here is, once the order domain, for example, publishes the order data, this order data should be accessible to multiple different applications. And what I mean by that is, if you were to look at a traditional messaging platform such as maybe MQ, what typically happens is once you produce the message, somebody consumes that message, and that message is no longer there after it has been consumed. It just disappears. But that is not the property which we want associated with this kind of a platform. The order data should also be consumable for by an inventory domain. The order data should also be consumable by a billing domain in whatever rate they may find best for them, right? For example, the billing domain may decide, okay, I want to consume this data only, let's say, once a day, right? So that should be possible. So Confluent and Apache Kafka makes it possible, because the entire premise of Kafka in this case is that it is PubSub, and you can keep data indefinitely in Kafka as per your requirement. It's all configuration driven, right? So there is a possibility in Kafka that you can go back in time and replay data. So for example, tomorrow, you have this requirement wherein an application comes in, and it's a new application, and they say, hey, I want to go through all the orders which have happened in the past, let's say 1 year. So all they have to do is just subscribe to the Kafka topic and go back in time 1 year, and they'll be able to retrieve all the orders which have happened in the past 1 year because the data is there based on whatever configurations you have set. The third principle here is that of self-service. Now, assume again, I'm a domain and I want to get data from all these different data sources. And I want to do something with that data, transform that data in some way, and publish that data so that others can consume. So how can I go about it? Right? The entire premise of this thing is I should not be dependent on some other team for me to get that data and provision that data for somebody else. Right? I should be able to do all that on my own without having to be dependent on somebody. So the first piece, so there are 3 steps here, right? The first piece is getting the data from uh, from different data sources into Confluent. And how would you do that? You could do that with connectors. So what are connectors? Connectors, you could think of them as config-driven applications. So you don't code anything. So let's say you have to connect to a database. The way you would do is you would have a configuration file wherein you put in the database URL, you have the port number, username, password, whatever, obfuscated, obviously. And then you just pass that configuration file, and connector would make sure that it's connecting to that source system and getting the data which it requires. So anybody who can actually go in and create that connection, and that data is available to you, right? It's a pretty much self-service there. So once that data comes in via source connectors into your data platform, what you could do is, what you want to do next is make sure that you are transforming those events or applying whatever logic you have to on top of those events. And for that, you could use either KSQL the one which I mentioned earlier, right? SQL over Kafka. Or if you want to have some more complex kind of logic, you could use Kafka streams, which provides a domain specific language to uh, uh, which gives you the logic and using which you can have all these complicated logic to filter filter out a certain events, to join multiple events coming in from multiple varied data sources. You can aggregate data, you can analyze all those data, so you can use one of those products to do that. So the second step here, so first step was the connector, the second step was KSQL using which you are processing that data, and the third step here is you want to publish that data. And typically you could do that over maybe a Kafka topic. And here, when we are publishing the data, one thing which is very important is we want to make sure that the schemas and versioning are proper. Right? So this is where the Confluent Schema Registry will help you. And what it does is, whenever we are publishing some kind of data, we want to make sure that it conforms to a certain schema.
Hey,
And even
Suraj.
as
Sorry,
yeah,
you've got about 30 seconds left, mate. Yeah.
okay, sure. Yeah, so we want to make sure that all these products are available to all the other uh, applications who are connecting to it, and yeah, and the schema registry kind of makes sure that your schema adheres to that. Yet your data adheres to that schema. So one of the things which Confluent helps you with in this case is data lineage, right? Wherein you can see how the data is flowing through each of your systems, right? And this helps you with tracking how the data is being transformed at each stage. The final piece in this thing is federated governance. And what I mean by that is we want to make sure that uh, even though we are talking about decentralization at each given point in time, we don't want uh, there has to be some method to the madness, right? And what I mean by that is there has to be some centralized governance still on top of that, because let's say I have a customer ID attribute in one domain. That customer ID attribute should also mean the same thing in some other domain. Otherwise, you will not be able to correlate that data. So that is why we say there has to be some kind of a centralized governance, although minimal, on top of your decentralized approach. This is more of a recommendation how you want to go about your federated governance. It's more of an organizational concern than a technological concern, and it would depend on how you want to go about it. Right? So finally, these are
Hey,
the
I might,
properties which actually,
sorry, Suraj, I
yeah,
might have to cut you off. Sorry. We need to be
yeah,
cognizant of the other speakers as well. Is
yeah,
there
yeah,
one slide that you can wrap up with
sure,
just
sure.
in 10 seconds? Yeah.
Sure, sure. So if you want to learn more about the data mesh, this is where you can go ahead, right? And just go to developerconfluent.io to learn more about it. Yeah.
Cool. Wonderful. Hey, sorry to do that to you, Matt, but just need to make sure we are careful with the timings and good to other speakers as well. So Suraj, thank you very much for that
Yeah.
talk. Obviously, a lot of content in there that you tried to put into that time. Can I invite you to
Yeah.
please, if people have questions, to answer them in the chat on the stage, the public stage? That would be wonderful as well. So, folks, if you have any questions for Suraj and the Confluent team, please pop them in the chat, and they will get to it soon. So, thank you very much, Suraj.
Yeah. Thank you.